Are we live? I'm not seeing a countdown.
You'll be live in 3 seconds.
Okay.
1 moment. I'll tell you. There.
Okay. Welcome. I'm David Walk. I'm a neurologist at University of Minnesota.
Hello, everyone. Don't worry. We will get David right back. No problem. Just wait 1 moment. They were trying to get me off the screen, but instead you have me, but not David. 1 moment. There he is. And we will get him. You're on mute, David, just so you know. So, David, you'll just have to unmute yourself and put your camera back on. At the bottom, you'll see the 2 icons. There you go.
All right. I exist, huh?
Welcome back.
Thank you. Thank you. Now you should be able to see my slideshow. Is that correct?
You bet. Yep.
All right.
You're good to go.
Okay. Well, thank you. So I'm David Walk. I'm a neurologist at University of Minnesota. I'm the director of our CMT Center of Excellence, and I'm pleased to have the opportunity to join today. A few slides that are kind of introductory, nuts and bolts things, much of which most of you may know, but we'll get started and go through it. I like to kind of take a step back and kind of put CMT in context for those who may not fully understand how we as neurologists see a CMT or a subtype like 1X. So this too small to read image is a overview of hereditary neuropathies, and CMT is right up here, top middle, but it's intended to demonstrate that CMT is not the same as a genetically determined or hereditary neuropathy. It is one and perhaps the most kind of prominent and common type. Some of its kind of sister disorders are other neuropathies here that are also typically autosomal dominant, but important exception we'll talk about here, but typically similar in terms of the genetics and their progression, except they may be only pure motor, for example, like DHMN, or pure sensory and autonomic, but are only neuropathies. And down below are other genetic neuropathies that are, most of which are associated with systemic disorders and might affect other organ systems. So CMT is a very specific type of neuropathy that is genetic, but not the only kind. Many of you are familiar with this, which is from Vera Friedman's review through the Inherited Neuropathy Consortium, which shows that among a large number of people living with CMT, by far the most common is CMT1. After that, kind of CMT2 undifferentiated and unknown, unfortunately. And I know that Dr. Zuckner is talking about VUSs today as well. And then after those is CMTX. So one of the more common forms of Charcot-Marie-Tooth. So that's a little bit of the kind of context. CMTX is a common, but not the most common form of CMT, which is the most common form of hereditary neuropathy, which can be either disorders of nerve only or systemic diseases affecting other organs. CMT itself has evolved. This is from Charcot-Marie's paper. So in the 19th century, CMT was simply kind of what we call a phenotype, meaning a description of symptoms and findings on examination with loss of muscle bulk in the legs and hands. And really nothing else, very little else understood about it, just a description of what physicians saw in the clinic. Then in the mid-20th century, we realized that one could classify into CMT1 or CMT2 based upon nerve conduction testing, when that became a more standard approach. Yet, interestingly, even in the 1880s, some of the papers do describe responses to stimulation. They had some very kind of early days ways of doing electrical testing, but not quite as quantitative as we had by the mid 20th century. So this is just intended to kind of illustrate that nerve conduction can be classified as slow or low. Basically, this is a normal response. This is this is a timeline. So this is the beginning, the time of a stimulus, and this is the size or height of the response. So normal is the response shows up quickly and you get a good high response. Slow is it takes a longer time to get the response, but the size is normal. And low is it shows up on time, but it's much smaller than it should be. Right? And so this is indicating a disorder of myelin. This is indicating a disorder of axons. And so it became clear in the mid 20th century that CMT1 looked like this and CMT2 looked like that. And so suddenly we had not just CMT, but we had CMT1 and CMT2. And then in the late 20th century and 21st century, of course, we're able to identify the specific genes and actually slice them up and look at the actual sequences. So we now know, of course, that there are a great many different types of CMT1s and CMT2s. And of course, we also know that there are CMT intermediates and CMT4s, so it's gotten a lot more complicated since then. But this is kind of the evolution of our understanding of CMT and classification, and this is where it kind of fits into the larger category of inherited neuropathies. So many of you know, but to again bring everybody up to speed, the genetic classification depends a lot on the genetics of a particular condition. So these are kind of family trees, if you will, each of these indicating a person. And blue is a person without disease, and red is a person with symptoms or signs, or if you like, with disease. So in an autosomal dominant condition, which applies to most CMT types, squares, by the way, are men and circles are women. No idea why that is, but that's pretty well standardized by now. So this is dad, this is mom, and this is kids. And so dad has CMT, mom doesn't. And in an autosomal dominant condition, dad has the CMT gene, if you will, on one chromosome, but not the other. That's why there's a blue and a red here. And one of their children didn't get this from dad and doesn't have CMT. One of their children did and does have CMT. That's why this individual is red. In autosomal recessive, the only way you get the disease is if you got an affected gene from both parents. So dad has only one affected gene and doesn't have symptoms. Mom has only one affected gene and doesn't have symptoms. Their daughter has only one affected gene and doesn't have symptoms. But their son happened by chance to get an affected copy from both mom and dad and has symptoms, has CMT, okay? And of course, CMT1X is the relatively common X-linked form of CMT. So X chromosomes are kind of special. Mom has two, dad has only one. But a child who gets only one X chromosome, we think of as at least genotypically male. And if you only get one X chromosome that has the change in the gene that causes the disease, you're going to develop the disease. If you get two X chromosomes, you may or may not have symptoms of the disease. So here are two daughters, one who inherited this X chromosome from mom and this X chromosome from dad and has no risk of CMT1X, does not have CMT1X. This daughter inherited the disease-causing X chromosome from mom and, of course, a normal X chromosome from dad, and is a little pink because depending upon how many of her cells have this one, or actually, I shouldn't say have this one, how many of cells express this one, she may have symptoms, and it's more likely than not that she will, but probably not as severe as her brother. So that's a little bit of kind of an overview of the genetics. And then in terms of the actual cause of the actual problem, the gene, the GJB1 gene, codes for a protein called connexin. And connexins do pretty cool things, which are not fully explained in this little diagram. But basically, they make gap junctions that can open or close. And it takes two sets of gap junctions to make a gap. But what these are is kind of secret channels. If you remember playing Clue, there was that secret passageway from the library to the kitchen. This is kind of like that. It's a secret channel from one cell to another in most cases. But in this case, it's actually a secret channel from one part of a Schwann cell to another that allows very small molecules like sodium or potassium or other very small molecules to kind of get quickly from one part of the cell to another. And they're there for a reason. They must do something important to make cells work normally. And in this case, we're talking about Schwann cells, which make myelin. And when they don't work properly and they don't have normal gap junctions, they cause problems with the axons, which then manifest as CMT1X. So this is really kind of the cause. It's an X-linked disorder that results in abnormal gap junctions, thereby causing abnormal trafficking of small molecules in the Schwann cell, making the Schwann cell sick, which in turn makes the axon sick, because as everybody knows in CMT1 of any sort, if the Schwann cell ain't happy, the axon ain't happy. So even though the mutation is a Schwann cell protein, a protein that's principally important in the Schwann cell that makes myelin, axons become damaged and you lose axons if you don't have healthy Schwann cells. There's probably what's called a kind of a gain of function pathology as well. It might be that in certain ways, having abnormal gap junctions actually can cause problems, even if you have enough of them. But that's a little in the weeds and less well established. So the symptoms, those of you who are on this know these symptoms because you're living with them every day. But for reasons that I pointed out, as a group, males are more severely affected than females, or people who are genotypically male are more affected. And that's because they don't have a normal X chromosome that would be expressed in many of their cells and make normal connexins. The appearance of the condition and the symptoms are very similar to most forms of CMT, including CMT1A, that is to say, gradually progressive weakness with some numbness or loss of sensation, most severe in the hands and feet relative to the shoulders and hips, developing over the course of a lifetime and progressing, and usually developing in mid-childhood, adolescence, and early adulthood. In that sense, it's very similar to other forms. A few differences are that the weakness can be less symmetric than it is, say, in the kind of paradigm of CMT1A or most CMT2s. And even within a limb, the weakness can be less universal. So, for example, the thumb muscles might be weaker than other hand muscles in people with CMT1X. So that's one of the differences. The EMG findings can be less symmetric as well. Typically, when we do an EMG on somebody with, say, CMT1A, every nerve, the rule of thumb that we teach our trainees is that there's kind of homogeneous involvement within nerves and across nerves. What that means is every part of the median nerve is going to be similarly abnormal, and every median nerve and ulnar nerve and radial nerve in the same hand will be similarly abnormal. That's less so with CMT1X. We'll see some differences between nerves or within nerves that are unusual for CMT and would make a kind of an uninitiated EMG physician say, oh, this looks like a different disease. This doesn't look like CMT. We know that CMT1X and a few other forms can have these kind of surprising appearances that are different from what we usually find in other forms of CMT. The other kind of big thing to know about CMT1X, and some of you may have experienced this, is episodic neurologic symptoms that imply brain involvement, even though we think of this as a nerve disease, not a brain disease. So these episodes are often are spells with abnormal speech, maybe some confusion or reduced consciousness, imbalance, numbness, or weakness. They are kind of they typically occur in the context of certain kind of stressors or metabolic circumstances like a viral infection, a fever, or another event that's kind of unusual but has been described is returning to a low altitude after being at high altitude for a period of time. These look like strokes, essentially. I deliberately didn't use the term stroke-like episodes because it sounds, concerning, and I'm not suggesting that they are strokes in the typical sense. They're not. They're not interruption of blood flow from a major artery, but they act like strokes in the sense that it's an abrupt onset of a neurological problem, a loss of function, and obviously when these occur, even if one has CMT1X, they should be evaluated urgently because you can't guarantee that it's not a stroke. But in this context, particularly in young, otherwise healthy individuals, by young I mean, children, teenagers, or young adults, it's something that's kind of characteristic of CMT1X, and with time, they generally resolve. There are rare exceptions to that. So those are a few kind of unique things about CMT1X. On the right side of this slide, I've placed a few things from kind of one of the prominent articles that compared men and women with CMT1X. And you'll see that, for example, let's look at things that are kind of clinically particularly important. Muscle weakness, 87% of the males, 52% of the females. This just indicates that that's a clearly significant difference. Functional disability. This is a scoring system that we don't commonly use, but it's 0 is no symptoms, no problems. 5, it's actually an 8-point scale, but in this group, 5 was the most severe, and that's requiring significant help with walking. And you can see, and 3 is difficulty walking, unable to run. And you can see that more than half of the males had difficulty walking, whereas only 20% or 19% of the females did. So this suggests that symptoms are common in women with CMT1X. It's not that they're all just fine, but as a group, they're not as affected as the men. Now, you can imagine that there's a kind of a recruitment bias here because a woman with no symptoms but who has the gene isn't going to show up in a clinic. Generally speaking, sometimes people come in, of course, because they want to be evaluated and they know it runs in their family. So there's a little bit of a selection bias when you kind of come up with this. But that said, I will say that amongst the people that I've seen with CMT1X, a great many of them are women. So to say it's worse in men does not mean it's not a problem for women living with CMT1X. I was asked to keep it short. We're going to do one more slide. Symptom management is very similar to what you heard about today from PT and OT and from Dr. Pfeffer. We try to do everything we can to help people live as well as possible, as safely as possible. And a lot of those are things that I think everybody who's listening in is probably familiar with. And in terms of treatment strategies, you heard a lot of that in the second half in this afternoon's presentations. Basically, you can target the tissue, which is a non-specific treatment strategy. So if there's a treatment to make muscles stronger or myelin healthier, that could be generalizable to all forms of CMT or CMT type 1. But when you get into something specifically about the protein product, so for example, PMP22 or connexin, or the gene itself, then you're dealing with things that are specific to the CMT subtype. And you heard a little bit about those kinds of strategies today. I'm kind of cognizant of the fact that oftentimes we hear more about PMP22 than about others. I know that our colleagues in the basic science areas are working on CMT1X as well. So that is that. I'm going to see if I can figure out how to not share the screen and get back to conversations now. All right. How'd I do?
Okay, you did really well. You did beautifully.
Okay.
Thank you for this amazing presentation. And we've got a few questions to go through. And as a one Xer myself, I am thrilled to be hearing all of this and looking forward to getting into the questions. So let's make sure everyone's got covered. Are there symptomatic treatments for CMTX? Also, any clinical trials? Someone is asking.
Right. So clinical trials at this point are limited. Everybody should be aware that clinicaltrials.gov is the way to access any trials, and um, we are required as investigators to enter them. There are, and that includes therapeutic as well as observational studies. So, for example, the Inherited Neuropathy Consortium is enrolling individuals with all of the common forms of CMT and rare forms in their natural history study, which is designed to understand how the disease progresses so that we can do a better job of understanding how to design clinical trials that are, interventional or therapeutic. Um, the other point that I didn't emphasize is that by collecting genetic material in clinical observational studies, we can also look for modifier genes. So some of you are probably familiar with the fact that we're all kind of affected differently by whatever we have for a lot of reasons. So even if it's a genetic condition that's due to a single gene, there may be modifier genes that basically kind of make it more or less severe.
Awesome. Here is the next one. All right. There we go. Okay. So it's saying my 15-year-old son had this happen after returning home from. Oh, no, that was not one. Sorry. I'm a female with CMT1X and was diagnosed at the age of 47. I had, excuse me, I've had terrible overactive bladder symptoms for 30 years and have been recently diagnosed with esophageal dysmotility and autonomic dysfunction. Just wondering if you know anything about this.
Yeah, no, I'm smiling because I love these questions and I anticipate them. So what I tell people is, we don't know what we don't know. I think Dr. Sahenk was also addressing this earlier today. One of the other benefits of natural history studies and talking to people like yourselves is that we learn more about conditions that we thought weren't part of those conditions. So yes, it's entirely plausible that those could be related. I'm not aware of a strong relationship, though. Um, the bladder symptoms are common in the general population, and there were some questions earlier today about autonomic disturbances, and autonomic nerves are kind of lightly myelinated or unmyelinated, so we don't think of them as typically associated with disorders of myelin. And there are some inherited disorders of autonomic nerves that are very severe and come under the category of HSAN rather than CMT. That said, again, we don't know what we don't know. And one of our jobs, I think, as CMT providers, is to try to help understand, what is related, what isn't. So I don't have a clear recollection of either of those being reported as associations, but I think there's a lot that we don't understand yet. And that's, I think, as a person living with CMT, the questioner has to be so mindful of, on the one hand, we don't want to say, like a lot of doctors do, oh, that's because of your CMT, when it isn't. And on the other hand, we don't want to attribute everything to this diagnosis and overlook other causes or treatments. So bottom line is get it checked out and get it treated. And the more we learn, I think the more we'll understand the relationships.
Okay, we have another question. Have you heard of any link between CMT and autism or developmental delays?
So CMT1X, I have not. And now there are other connexin-related conditions, different connexins. So this is GJB1. There are others that are inherited and can affect central nervous system. I think there's, and I don't recall exactly which one it was, which connexin it is, but that does present with developmental delay. But if it's CMT1X specifically, I'm not aware of a relationship. I should add one other thing. There is a report.
Sure.
There is a report which Dr. Shai's group published years ago of somebody who had repeated episodes of the sort that I described that left persistent deficits. So they were stroke-like, but actually without full recovery. So I suppose, I don't think that's what you're asking about, but that is a circumstance in which it is arguably possible to have progressive kind of brain disease related truly to CMT1X. And I'll make one other comment about that.
Sure.
Those spells are probably mutation specific. So, there have been 400 or so mutations in this gene that have been described that cause disease. Most of those are not associated with those spells. Some are. So the likelihood of having events like that is not uniform across CMT1X mutations. So that's why it's also, and this is another kind of really important point that we probably don't emphasize enough in clinics. With CMT1A, it's a duplication, and that's as well as we can characterize people today in terms of their genetics. But with CMT1X, there's more that we can say, and same thing with mitofusin and some of the other forms. The specific mutation becomes important and might have some importance in terms of what your symptoms would be. So knowing the specific mutation in the GJB1 gene that you and your family have could be valuable, because you might be able to determine, for example, if there's been evidence that you're at risk for those kinds of spells or not.
Awesome. We have a question here. Are there different types of CMTX, or is there just CMT1X?
Right. Another great question. So there are different types of CMTX, or to maybe put it another way, there are different X-linked inherited neuropathies. The others are extremely rare. CMT4, CMT4X, 5X, and 6X. 6X, I believe, is only in early childhood and a fairly severe disease, relatively speaking. So there are other forms. They're very uncommon. CMT1X is the biggie. And again, as I said, to kind of riff a little bit on that question, not only are there other forms of CMTX, but there are different forms of CMT1X, as I was just explaining, and there are other connexin-related diseases. So the Venn diagram gets a little complicated. All that said, if you've been told that you have CMT1X, that's what you have, and nobody in your family is going to get CMT4X or 5X or 6X or some other kind of connexin disease.
Is there any connection between CMT1X and COPD?
None that I know of. Again, same caveat as before. We don't know what we don't know. And if your doctor knows of it, I want to hear about it.
And a good, I think, final question to wrap up with. We had a member ask, where is the science on CMT1X genetic treatments in your estimation? Because we know it's a guessing game. Are we 1 year away, 5 years away, 10 years away, or longer?
Okay. So there's a bottom line question. I think we're probably between 1 and 5. I mean, again, Dr. Cleopa has done extraordinary work on so many of these genes. He's really the uber leader, and has done he and others as well. But I'm just basically giving him the shout out he deserves. I'm not saying it's only he, but there has been some pretty sophisticated work already done on gene delivery in CMT1X. With very encouraging outcomes, again, in animal models. So I can tell you that I think that the route is paved. I think we could do a lot better than 10 years. So and hopefully more in the 1 to 5 range. One other point to make, going back to that last question, again, if you've been told you have COPD, make sure that that was accurate, because again, I think that oftentimes um, non-neurologists will make another diagnosis and be less aware of the potential relationships. So people with fairly severe neuromuscular disorders, or let's say a fairly severe CMT1X, could have some breathing difficulty, could have something affecting the nerve to the diaphragm. And if somebody's not looking at your breathing test carefully, could make the wrong diagnosis. I'm not saying they have, but just be sure that that was correct.
Yeah, and the other thing I would say to your earlier points, taking advantage of the moment as a CMTA admin team member, is that the exciting research that's happening, all of the amazing breakthroughs that have happened so far and are yet to happen, are currently funded by donations coming into the CMTA that we then can put these guys to work. And so I very much want to encourage you, every time you see that we're doing a fundraiser, if the youth are doing a fundraiser, the adults, if you're considering where to donate money and a cure or treatment for CMT is high on your priority, trust that, again, 90% of what we bring in goes directly to this mission. So I just want to encourage everyone to keep giving, because this organization is laser focused on treatment. And I just want to, on behalf of all of us, say thank you to David for your time and for your expertise and for informing us a little bit of what's going on behind our diagnosis number and letter.
Great. Thank you so much, Jonah, for the opportunity.
My pleasure. My pleasure. And everyone, the 25 of you, I am the official thank you for a wonderful day. Thank you for being with us and staying with us. And as always, if anyone has any questions or anything that they would like to follow up on, please never hesitate to reach out to us. We are here for you. Have a wonderful, wonderful day, everybody.